Today I just wanted to bring you a video mostly just reviewing, just kind of taking a quick look of this new product, quote unquote new product. It's been out for maybe a couple of months now. Grizzly Conductonaut Extreme. This claims to have a 30% better performance than the traditional Conductonaut. I don't know how that can be verified. I mean, this is based on gallium. It is a gallium-based product, really, with small amounts of other alloys or other metals in it, metal alloys. But let's look just briefly at the specifications here. For the traditional Conductonaut, you don't get that much as they do here with the new product. Okay, so let's see. Recommended temperature 10 Celsius to plus 140 Celsius. Okay. Now here you're looking at operating temperature minus 50 Celsius to 200 Celsius. So apparently they made it so that it could withstand these temperatures. I mean, if you were to try to go to minus Celsius here, 50 Celsius with a traditional Conductonaut, it would just break down. It would just crack or just fail completely and leave you with a failed thermal interface material. So see what else. Nothing else. Nothing really like that stands out other than the operating temperatures, the tolerance. But my understanding from an email that I got from them is that the new Conductonaut, it's supposed to have a 30% better performance. Now, what does that mean? Like in terms of what? Thermal conductivity, longevity. Let's just go ahead and jump into the video real quick and see if through testing, through just having a little fun, through testing, we can see if there's any difference between the two in terms of thermal conductivity. Yeah, let's get into the video. Hey guys, so we're going to take a little relaxed approach to this whole thing. Here's the two products. I already been using this one here. This is the 5 gram option or offer, whatever. This is 1 gram. So let's first look at the 5 gram little tube. It comes with black cotton swabs that Grizzly likes to use. This is nothing special here. You can almost say there's nothing to see. So let's open this up together and see what this looks like. What is inside? I don't expect anything different than what you get with the conventional or normal Conductonaut. I'm sorry, Conductonaut. Let's see here. Okay, so you get some papers here telling you what not to do and what to do. More information here. And some cotton swabs to remove thermal paste. Okay, great. You get this here. Oh, look at that code. You want that code? Who cares? All right, here we go. Let's see. Alrighty, so you get yourself a typical microscopic tip, which I advise strongly against, and this one here also. Just don't use this stuff, and I can tell you, these are the black cotton swabs, by the way, included. The reason why I don't use these things is because let's just say you're not familiar with this product and you never used it, okay? I'm talking to you. When you go and put this on, let's go like this, and put this on, and you start squeezing this stuff through this little tight surface, it will come out bursting out. It will like squirt all over the place. And if your graphics card is in the crossfire, you're gonna have metal, liquid metal all over it, all over the circuit board. And at that point, may the Lord be with you, okay? Let's just say that. The same thing goes for this thing here, okay? So if it's your first time or you're not very comfortable with this, you know, used to learning or just whatever, even for guys that have been doing it for a while, this stuff right here can be a mess. I prefer to do this without those things. I prefer to just go slowly. See that there? And directly like this, I'll just dab onto the die or the IHS. And then I'll spread it with the cotton swabs. This assures me that I will not have a squirt all over the place. No oopsies. And it is a lot more manageable. Like, you know, like you can see here popping out, in and out. Okay. And I'm just pulling back. Now everything goes in. So this is, you can control this way. But anyway, here is the little tube. This is the 1 gram tube. Okay. So the difference is apparently that with this you get a white tip, you know, to tell you, hey, this is super duper, and the other one is not. Yeah. So that's for that. Okay. So I am full disclosure. Let's bring this thing into the camera view. Let's put this stuff away. Full disclosure, I have already...
I'm back.
I have already applied Conductonaut, I should say. I keep saying Conductonaut. I don't know what's wrong with me. I have Conductonaut already applied on this little 470. This is the car that I use for it's like my little lab rat. And I can tell you that there's a significant difference in temperature versus conventional thermal paste versus, for example, MX6 or even Conductonaut Extreme, anything. This stuff will always be better, okay, because it's just metal. Just the thermal conductivity is just naturally better. So this already has Conductonaut, but not the Extreme. It's just a regular Conductonaut. Another thing that I got to tell you, and I got to maybe go over, is that, and I will get a lot of people saying, no, that blah, blah, blah. This is, you know, contradicting me on this, but I know this from experience, okay? And even if you email Grizzly, they will tell you the same thing. When you applied liquid metal to, say, copper, because this is what the case is here. This does not apply to coolers that are nickel plated. This is only for copper. Okay, let me make that very clear. In case your plate, your contact plate underneath here is made out of copper, you need to apply liquid metal or Conductonaut twice. The first application, you should run it for 1 week to allow for the infusion of the gallium into the copper, which basically what it means is that it will create a white silvery layer on the copper. This does not degrade the copper. It does not affect its thermal conductivity in any way, shape, or form. It doesn't affect it, period. The only difference is aesthetically. It's just, you just have that big white stain on there.
if you want to call it a stain. But that is necessary. That is necessary for the optimal performance of an application. The reason is, and this is what was explained to me in the first place, and I have tested it, and yes, that is correct, is that if you apply it only once and you install it and forget about it, what will happen is that the application, if you did it correctly and you put a small amount, that small amount will be absorbed by the copper. And now what you have is a smaller amount of liquid metal between the heatsink and the die. So your temperatures might go up because you just don't have enough thermal conductivity because you lost some liquid metal there in the process of the gallium infusing with the copper. So you apply it once the first time, wait for about a week, just to use it like normal, and then take it apart, wipe it off. Don't do anything to the cooler, to the copper, maybe just light cleaning or whatever. Maybe you can use something like this. This you can find at any hardware store where they sell wood and construction material, or mostly in those places. This is not sandpaper. It's just a little rough kind of, to really scrub metal and give it, bring it back to its, clean condition. This will not remove the gallium from the copper. It will just polish it. Okay, so you can use this safely. They come in big squares. So again, you take it apart after about a week or 2 weeks, whatever. Run this over the copper just to make sure you get all the any residue of liquid metal that might have hardened on the surface, just to make it smooth. And then you clean the die with alcohol, and then you apply a second application of liquid metal. And that will be your final one. You'll never have to replace that again. It will just last for as long as you own the card. As long as this thing exists, that liquid metal will be there. That'll be the last time you have to apply a thermal interface material to that particular card. The same goes for a CPU, even surfaces that are nickel plated. It's the same thing. With nickel plating, you don't have to do what I just mentioned. It goes without say. It doesn't absorb into the metal. So anyway, let's go ahead, and what we're going to do is install this into the system, run a 30-minute benchmark of Unigine Valley for 30 minutes, and I'll show you my settings here in a minute, so you understand what kind of parameters we're working with. Okay, let's get into it. All right, guys. So now we're on the desktop. We have the card installed. Let's zoom in a little bit. Okay, so here's the idea. We'll set the power limit to plus 20. Lock this fan speed to 50%. We will lock our frequency to 1100. And we will not tinker with the core voltage. We will leave that alone. Okay, so this will be our profile that we'll use for every test run. Okay, so let's go ahead and open up Valley Benchmark. We'll run it in window mode, not full screen. Okay, so we'll go there. Get this here on the forefront. All right, and you also have information here on the side. If you're interested in that sort of thing. So we will let this run for about 30 minutes as it is. And at the conclusion of the 30 minutes, we'll see what the peak temperature was. And then we'll run another test with conventional thermal paste. So we will use the best that we got. And the best that I have is either MX6 or Conductonaut Extreme. It's kind of a hard choice. You know what? I got plenty more Conductonaut Extreme, so we'll use that. And then after running Conductonaut Extreme and comparing the temperatures to Conductonaut, we will run Conductonaut Extreme and see what the difference is between the three, or yeah, between the three. All right, let's get into it. All right, guys, so we have concluded our test here. We have reached 30 minutes, and the temperatures fluctuate between 66 and 67, as you see there on the screen. Nothing surprising. So let's go ahead and stop the test here. And we will take the card apart. We will add Conductonaut Extreme and rerun the test for another 30 minutes and see what type of temperatures we get. All right, let's take this thing apart. And remember, this is Grizzly Conductonaut. This is the standard version, not the extreme. I don't even know what you will call the first one. Just call it the first Conductonaut or Conductonaut. The first Conductonaut, that's what's here, okay? Come on, there we go. And we're gonna have a look and see what liquid metal looks like after about a month. Okay, here we go. And that's what that looks like there. And the reason why I used colored nail polish is because I want to see what is covered properly and what is not. If you use see-through, it's your choice, you know, whatever you want to use. But if you use see-through nail polish, I forget what that stuff is called, then you will probably miss some areas, you know, as far as thickness. So you can see here, all the SMDs are covered. So, and here's the cooler. So you can see there's a small little bubble there, bottom left corner. So apparently I added a bit too much to this, but that's okay. No harm done. So let's take this apart here, put this aside, wipe this clean, and I'm gonna try to not to make so many edits to the video. I'm going to try to keep it as uncut as possible. Not because I think that I am super entertaining, but because I want you guys to experience everything, even the mistakes that I make, like this one here. See this little, this little punk here was trying to run away from me, and if I would have missed this, and if these SMDs were not covered the way you see them there, this would have been a mess. A mess that I really wouldn't want to take time to fix, even though I would do it anyway. But you get the point, I think, right? Okay, there might be some here at the bottom, so I'll pick that up with the cotton swab. Okay, and I think that's good enough there. Let's see if we got anything here that is hiding from us. Yeah, there was a little bit there, but I think we got it now. Let's take a closer look. I think we got all the liquid metal, yeah? Yep. If you're gonna do, and I think this goes without saying, if you're gonna do liquid metal on a direct die contact like this on a GPU, you should, or let me rephrase that, you must cover the SMDs that are near the die like this. You have to use some sort of protection, because yours truly here, you see that right there? You see that? That could easily just roll off the cooler and onto the SMDs here and short your card and possibly kill it. I've had this happen before, and fortunately it did not kill the card, but very risky and very noobish of me to do. Matter of fact, now that I got you in frame here, let's just clean this up real quick. And as you can see, the cotton, or this little pad here does not pick up. It doesn't do a very good job at picking up the liquid metal. No, it just kind of like smears it. It rolls away from it as you swipe across. So I think the best way to do this would be to try with the dry cotton Q-tip and just pick it up. Or maybe make it worse, I don't know. And see that area there? I'm going to go to the sink and spray this so that we can get that out of there. I'll do it off camera. I'll be right back. All right, guys, we're back. Remember what I was telling you about this here? See how this looks? We want to clean that up real quick, just to smoothen things out. And again, it will not remove the fusion of gallium with the copper there. It will just, this here will just polish the surface so that you can get a smooth contact with the die. And this stuff, your paper should look like this once you're done. Something like this, yep. And that looks pretty clean to me. And see, that's what I was telling you, that layer there, that's what you want, okay? And in the past, I've gotten a lot of criticism because of my using of liquid metal on copper, but if you want to use liquid metal on a copper surface or just on a GPU and it happens to have a copper heatsink, this is what you got to do. No harm done, but you know, there are fellas out there, people out there that have a different opinion than yours, so I respect that. So, time for Conductonaut Extreme. You know what, I just noted that these pads here kind of lifted. That's my VRM pads, and I don't want that to give me any trouble, so yeah. Okay, here we go. Conductonaut Extreme. Let's see. Ooh, that's a lot, but you know what? I got plenty of it, so it doesn't matter. And I keep this stuff in a bag like this with MX6 because I want it to last. I don't want it to go to dry and then become hard to apply. So that's why I do that. Consider this a techie ASMR video, okay? If there is such a thing. Okay. And this stuff is pretty thick, although it is easy to apply, but it is pretty viscous. Viscous. Yeah, you know what I mean. And you just kind of have to let it just glide. You can't push it, you can't pressure it. It's just, it has to just let it just run over the surface like that all the way to the end, and you get that perfect application there. Get this corner here and this one up here. All right, yeah, that looks good. Okay, so let's go ahead and put this together. Okay, so we're ready for our second run. Let's get to it. All right, guys, now we're back at the desktop. Let's go ahead and pull up MSI Afterburner. Load up our settings. Apply them. And then rerun Valley Benchmark. And I will see you in 30 minutes. All right, guys, we have reached 30 minutes. The temperatures for Conductonaut Extreme have reached 70 Celsius. It mostly stays around 69, but here and there it rolls over to 70. So we'll say 70 is the peak temperature. This here speaks to the good quality of Conductonaut Extreme. This is why I like this paste, and I have it on most of my GPUs that I use for whatever. But yeah, let's go ahead and stop this test and move on to Conductonaut Extreme. By the way, the ambient temperature is 22 Celsius. All right, let's go ahead and take this thing apart. First, let's get these here out of the way. Okay. So, as you can see, that was perfect contact there. So, real good contact. That's what you want, right? Okay, let's get this cleaned up and then move on to Conductonaut. All right, guys, so now it's time to add Thermal Grizzly Conductonaut Extreme to this card. And let's see where that 30% performance improvement is allocated. Let's see where that's going. Let's see if that's a thing or it's just pure marketing. Now, I have gotten a lot of comments in my previous thermal paste videos about trying this on in between CPU and AIOs, you know, that sort of thing. But I think, and from my experience, from my testing, that I have learned that the best way to test liquid metal is with direct contact, you know. So meaning direct die contact with the cooler or whatever thermal solution you have. I don't believe that you will get, as far as experimenting, I don't think that you will get quantifiable data from testing this stuff between an AIO and an IHS. The reason is because you have multiple layers between multiple surfaces between the die and the ultimate, you know, where the heat is going to be dissipated. Like, for example, In a CPU, you have obviously the die that's creating the heat. Then you have, depending which, and most CPUs today are have an indium sheet on top of them. Okay, so you have the die, then the indium sheet, and then the indium is actually thicker than the liquid metal, so that's also the heat has to travel through that, through the IHS, and then through the IHS, through the thermal paste, and then through the thermal paste to the heatsink or AIO cold plate. So that's a lot. Okay. Now you may argue, okay, for that same reason, it would be good. This right here could be a significant improvement because you could argue that this will compensate for all that, all those layers that the heat has to travel through and improve ultimate temperature. So yeah, that is a valid argument. However, if you want to get just for experimenting, like measuring things, like what is how good this is the method I have found to be the most reliable. Just directly on die and the cooler. I want to test this, not the indium sheet, not the thermal paste, or the IHS or any of that. I want to test this. I want this compared to what? To the other stuff. So this is why I do this. This is why I do direct on die testing. I don't bother with IHS or anything like that. So, okay. So if you're gonna do liquid metal, this is how you want to have the ending result, like this. If you add more than this, you'll end up with the bubble that you saw when I first took apart this thing. You end up with a bubble like that, which could easily just drip and just cause havoc, especially if you don't have these things covered like this, protected. So anyway, let's do the same to our friend over here. Okay, we need to apply liquid metal to this surface as well, and we're going to do it the safe method, just like that. We're going to apply just a little dab. There you go. That's all you need right there. Let me show you up close what I'm talking about. Just a little dab like that right there. That's the best shot I can give you. You don't need much. If you apply more than that, you're asking for trouble. And this right here will just take a little time, but just go along with it. Take your time to spread this properly, mirroring the pattern left behind from the thermal paste, or if you were using liquid metal before, the pattern left behind from the previous application. Just mimic that. Okay, just follow that. You can do this in circles, you can do this up and down, however you like. The important thing is just to get this equally uniformed on your cooler. And you just want a thin application like this. No bubbles, no puddles of this stuff, because that's just trouble. You're asking for it. And this is very close to the aluminum, so I have to be very careful here. Okay. And the fact that the copper has already infused with gallium makes this application here a lot easier. Okay, there you go. Okay. That's how you want to have this, or similar to it. Sure, you guys could probably do better. I'm doing this kind of a rush here because I do have other things to do outside of YouTube. But yeah, I'm trying to do it as best that I can so that we get reliable data. Even though I am doing this for fun, these results are to be taken with a grain of salt, like I always say. But I do try to keep some consistency in what I do. So, okay. Let's go ahead and put this thing together. Remember, this is now Conductonaut Extreme. Okay, so here we have it. Conductonaut Extreme, ready to roll. All right, let's fire up the system. All right, guys, we're back in the system. Let's go ahead and okay, the settings are already applied automatically, which is nice. Okay, that's good. Let's go ahead and get valid benchmark here. All right, let's fire this up. Give me a second here to get this in order. Alrighty. I'll see you guys in 30 minutes. All right, guys, welcome back. So it's been 30 minutes now. I have to break this down for you because this I was not expecting, okay? As I told you, I have locked the frequency. I have locked the power limit to plus 20 millivolts, and the temperature, the fan speed to 50%, okay? But the voltage, I leave it as default. So the card can do whatever it wants, pull however much power it needs, depending on the thermal overhead. The temperatures with Conductonaut Extreme have stayed the same, 66, 67. Sometimes it rolls to 67. Mostly it stays at 66. And I thought, okay, well, that's not so impressive. But then I looked at this here. You have to focus on these numbers here. And this, okay? Pay attention. 103, 102, staying at 66. And sometimes the frequency, once it's pushing, it wants to boost. But obviously I'm not letting it because I locked it. But here and there, it goes to 1120, 1130. As you can see there, it's already boosting. The power consumption goes to 104 watts, 105 at times, mostly staying at 103.5. That's the average that I've calculated. And also staying at 66 Celsius. So the thermal overhead is allowing the car to want to boost. It's pushing the you get what I'm saying. But yeah, the thermal overhead is allowing for a higher boost. So if I was to just let this loose, this thing will boost. It'll have a more steady frame time line that you see there, that you see here. It'll be a more smooth line there without less hiccups, less dips and frames per second and so on, because it's just more steady, more consistent. But look at that. Now, to put it in perspective, Conductonaut, the first edition, the first Conductonaut, the wattage, the power consumption stayed around 97, 98. Sometimes it'll hit 99, but it'll roll over to 67, mainly staying at 66. As you saw right now, the temperature went down to 65, and 66, 65, 66. So, but this is with Conductonaut Extreme. But back to Conductonaut, the first one, the power consumption stayed under 100 watts. That's what I'm trying to say. Perhaps it might have gone to 100, but no, that was not the case. It was mostly 98, 97, 99, around there. With Cryonaut, the power consumption stayed relatively the same as Conductonaut. Cryonaut Extreme, the power consumption stayed around 97, 98, around there, 99, but the temperatures went up to 70. So yeah, there was no boosting there, no thermal overhead. Bottom line, this stuff, I guess, it works. I guess whatever Grizzly put into this stuff, it's doing its thing. It's yeah, I have to say that it's doing good. It's working. It actually has that thermal overhead. I'm seeing it with my own eyes, as you're seeing there. The card wants to boost. It's opening up the power consumption for this thing to boost, because in order for to have higher clocks, obviously you need more power, and the card here is saying here you go, more power, because it's that thermal overhead. But anyway, take these results with a grain of salt. I think this stuff it's good. I'm not gonna say it's not, because it is. It's quantifiable data there. So yeah, as far as longevity, that is to be seen. I hope that this stuff doesn't just like, I don't want to say evaporate, but I hope that it stays thermally conductive. I hope that it's consistency, like it's a consistent product. That's what I'm trying to say. Even though I know it's liquid metal, it shouldn't break down. But you know, anyway, I think this is all I got for now, guys. I'm gonna put up a graph here to show you guys what the the numbers look like, to get a better understanding. But yeah, I am impressed. I am, yeah, I like it. I like so far what I'm seeing. So yeah, I'll leave it here. If you haven't subscribed, please do subscribe. If you like the video, please hit thumbs up. If you don't like it, you know what to do. I appreciate any comments, any questions. I'll do my best to answer. So I'll see you guys in the next one. Before I go, I'll put the graph up on the screen. Take care.